Okay, good morning everyone. My name is Brandon Heinz, and today I'm going to be presenting my PLC-operated beverage dispenser. Okay, so problem statement. The problem statement is to design and build a more efficient device for dispensing alcoholic beverages in bars, clubs, or pubs by using a PLC-controlled design. My device aims to simplify and speed up the process of getting a drink to a customer, therefore increasing profits. Okay, so project aims. As most of us know, it does get a bit stressful and hasty in the bar environment. My design will assist in the bartenders not mixing up drinks or perhaps grabbing the wrong one. There will also be less stress on the customers as they won't have to wait forever to actually receive their drink. Now and then, bartenders could get distracted for a second, maybe pour too much to drink, or too much alcohol, too much Coke, therefore not making it taste nice, and even maybe make a mess and spill. My product requires hardly any human interaction, and other than a few buttons being clicked. It's very compact and simple to use. It's affordable for small operations, and is easy and quite enjoyable interaction with the machine. So my project research, I did lots of research when I previously built something similar, but I used an Arduino design. Obviously there's the conventional water dispenser that most of us have in our homes. Then there is the smart tender, which I will be speaking more about in the next slide. And then there's Arduino based designs like my previous build. Okay, so the smart tender, it's very large in size and does take up a lot of space, especially in a bar or club where space is often very limited. The price of one of these also doesn't come very cheap at all. Costs approximately $30,000 to have one of these. And the cost of maintaining it is also a bit of a problem as there's a lot of smaller components to it. Okay, now I'm going to go on to how I designed my project. I began by first programming it and simulating it on the Logo Soft Comfort program. After that, I gathered a bill of my materials, and then after that began wiring. And then I'll also explain how my project works. Okay, so here's the programming part of things. I used block programming. As you can see, there are a lot of basic function blocks like the and or blocks. For the and blocks, there's a little and sign, as you can see. Oh, yeah, there you go. Okay, so for the and function block, both inputs here need to be set on a high state in order for a connection to successfully run through. And then there's an or function, which is here, which basically you only need one input to be on a high or an on state in order for the connection to successfully run through. There are also four on and off delays, as you can see there. And they basically act as timers. The first one at the top is for the single brandy and is an off delay. It is set to only 2.5 seconds and 2.5 seconds, yeah, so that it fills approximately 1 shot glass. The second timer down here is an on delay, and it only sends a signal once the 2.5 seconds at the top are done, and then the Coke starts pouring out, which you can see here. Then the same is applied to these two at the bottom, just the timer is set to 4 seconds, which imitates the double brandy being poured. Okay, here's a bill of my materials. I used a logo module, some wires, power supply, 3 switches, 4 LEDs, circuit breaker, and then 2 solenoid valves. The cost amounts to about just over 5,000 Rand. Which is a bit expensive. Luckily I didn't have to pay for any of it. All of it was supplied to us. Here's a picture of my fully assembled PLC design. As you can see over here is a little power brick. This is the circuit breaker, and this is the logo module over here. And down here we have 3 switches. Then there's 3 LEDs down here. Well, actually 4, but the one doesn't work. And then 2 solenoid valves on either side. Okay, so how my product actually works. It is very simple. That's why it's so user-friendly and enjoyable to use. There are 3 switches. There's 1 power switch, there's 1 switch for the single brandy, and 1 switch for the double brandy cook. First you have to obviously switch on the power switch. Once that is switched on, you can choose between single, double. So once the, say, single brandy switch is flicked, it pours out for a given amount of time, which I've set to 2 seconds, until it has reached that desired spot. Right after that, the Coke will start pouring out until the same switch is flicked to stop the process. Okay, now onto some personal self-development and PPD. So at times it was difficult to try and understand certain topics as I didn't seem interested in it. But over time I have come to notice that it has in fact helped me quite a bit. And my people skills, I would say, have improved immensely, and it has helped me to better my communication skills with certain individuals. This will also, I would say, give me an upper hand in the corporate world, as I will encounter very different types of people. Okay, so some technical difficulties that I had. For one, being the biggest one, as I only managed to put together the electronic components. I didn't get to actually making a structure of some sort for the liquid and electronic components to fit into. Another difficulty that I had is that I had to eliminate the use of a load cell, as I couldn't get accurate readings or couldn't get them to work together, the PLC and the load cell. So I had to improvise and change my product to what I have now. At times I was also very limited to what I could do with my project, because at home I didn't have certain tools and things like that I would have at college. Lessons and skills learned. Obviously the biggest one is I learned how to use the block programming, which was actually quite enjoyable and fairly easy to learn. Next was time management. That's something I have to kind of work on, I think, because of COVID, being at home. You think you have more free time, but you actually don't. And then wiring was another thing. Learned how to properly wire, put together the PLC design, and then learning about PLC components such as the logo module itself, how it works, circuit breakers, and things like that. Cool. And to conclude my project, there are definitely more things to do to furthermore improve it, but I did, however, have fun making it. It does work, and there are obviously things I can do to make it better. There were some ups and downs, but I'm very satisfied with what I managed to come up with. Thank you.